on the second day of 9.2, we're still going to solve by graphing, but today we're really going to capitalize on using the technology that we have to help us solve by graphing when our x-intercepts are not very obvious, okay? So yesterday, we tailored your assignment very specifically so that every single time you graph that parabola, it was evident and clear exactly where that x-intercept landed. Okay. Sometimes you could probably also just see it on the table because it typically was one of the points that you were, able to plot. Okay. But the reality is, there's a lot of times, like these 3 examples up here on the board, where you have a parabola and it's going to intercept the x-axis and it's going to have at least one solution. But when you look at it, it's not going to be obvious what that solution is because it doesn't land on a whole number. Not all quadratics have whole number answers, okay? Sometimes it's a decimal, and as soon as it's a decimal and that little, x-intercept right in here, for example, is landing between, 2 and 3, all of a sudden we're playing a guessing game, right? It's like, well, it kind of looks like it's at about 2.6, but who knows, right? So we don't want to play that game. We want the exact solutions, and for this type of quadratic, when it doesn't land on a nice whole number, or we can see it on the table because it's a whole number, we use our technology to get that exact answer. So that's really what our focus is going to be on today. Is we're still solving by graphing, but we're going to be using the graphing calculators to get the exact solution. And the method that you use today will work for all the ones from yesterday and these. I mean, it'll find the answer, whether it's a nice pretty 5 or an awful negative 9.247812, whatever, right? So that's the idea. So make sure you have your graphing calculator because that's what's, and then the other thing that we're going to do today is we're going to do some regression work, and that is all review. You've done linear regressions, you've done exponential regressions, and so today we're just reviewing how to do, the stat and the quadratic regression and so forth for a quadratic, but the steps will pretty much all be the same, okay? So let's start with this guy. Before I jump into the calculator, I just want to explain to you what happens inside the calculator so you understand what you're doing. We're going to let the calculator just solve this for us. It's going to just find those x-intercepts. But remember, this parabola has arrows on the end because it goes on forever and ever and ever. And remember, our calculators are not very smart. Okay, so if I just gave it a directive to say, hey, find a point, it would probably spend the rest of its life looking for points along an infinite curve because the curve doesn't end. So we've got to essentially give it some parameters. Okay, we're going to limit where it looks so it can find it quickly. Okay, so it doesn't just get into a loop where it's looking forever. Okay, so when we grab our calculator, we're basically going to hug the x-intercept with some bounds. Okay, so you'll see this makes sense and more sense in just a moment. But if this is the first x-intercept that I'm interested in finding right in here, then what I want to do with the calculator is basically just create a left-hand wall or boundary and a right-hand wall or boundary that kind of hug that x-intercept right in between. There's no like perfect distance. You just want to be a little bit to the left and make a left boundary, and a little bit to the right and make a boundary, and just make sure that that x-intercept is chilling and hanging out right in between those two limits. And then we'll tell the calculator, look in here, just look in this little space, and then boom, it finds it really fast, okay? So that's what we're doing when we find those boundaries. Yes? What do you mean? And are you in your y equals, and then you have your table. Somehow you change your table status. See, it's like your independent variable. You're setting it to S. So if we put it on auto, there we go. That should work it. Okay, so let's get started. Are y'all ready to try this out with a calculator? Okay, so we're first doing this guy. It's going to be x squared minus 3x plus 1. So let's grab our graphing calculator. And here we're going to go to our y equals. We're going to enter that equation right into our y equals. So it's x squared minus 3x plus 1. Is that right? Minus, let me move this over, 3x plus 1. Okay, make sure that's accurate. And luckily, they already gave us a they already gave us a graph of this. But if we want to graph it just to make sure it looks, you know, the same and we didn't enter anything weird, you can do that. So there's the graph, very much like the one that you have on your handout. And for this one, it's obvious right here. We can see right away that our intercepts land in between whole numbers. So that's the whole predicament. That's why we're here today, right? Our intercepts are between whole numbers. They're a decimal of some sort. It might be a 1.5. It might be a really long irrational decimal. But we're going to have the calculator find out exactly what it is. So step one, pick which zero you're going to find. Okay, because there's two of them. Do y'all agree? We have two solutions. So you're going to do one, and then you'll go back and do the other one. It doesn't really matter which one you do first. I like to just always go left to right because that's how our world works. But you could pick either one. Okay, but I'm going to go ahead and focus on just finding this solution right here, this left-handed x-intercept. I'm going to do that guy first. Everybody okay with that? All right, so then to calculate that, I'm going to go to this blue calc menu that is above the trace key. Okay, and I'm going to show you my keystrokes here in case I lose anybody. There you go, clear that out. Okay, so if I want to go to that blue calc, I know I have to press the second key and then the trace key. And here's my options. These are all the things I can calculate on any kind of graph. And what do you see there? 0, right? So it says 0, but we know that 0, root, solution, x-intercepts, those are all synonymous. They're all the same thing. Okay, so what we want to calculate is the 0 of the function, which is the same thing as x-intercepts. So you can choose that second choice. Okay, now pay attention to what it's reading down here. Right now, it's just asking me to set up a left boundary. Don't just be like, oh, it's a 0, 1, that's my answer. No, you haven't even set it up to solve this yet, okay? So right now, we're just setting up a left boundary. And I'm actually already to the left of my intercept, but you would use your right and left arrows here to kind of move along. And just make sure you're just a little bit to the left of that intercept, okay? There's no right or wrong distance, you know? Just be to the left of it. And then you hit enter, and see it immediately creates that boundary. If you have some of the older operating systems, I don't think it shows you that vertical dotted line, but it'll show you a little arrow at the top, I believe, like a little arrow like this guy. So you know you still made it. Yeah, the newer ones have this dotted line, which is nice, but not necessary. But now it's asking us for a right boundary. So now I just kind of scoot over to the right, make sure I pass up that intercept and get to the other side of it, and I'm slightly to the right of it. And then I hit enter again, and I create a right boundary. And if I did that correctly, right, I should have one intercept, one x-intercept, kind of right in between my boundaries. Okay, it's just kind of being hugged right in the middle. Okay, we haven't solved it yet. That's why this still says guess. So don't sit here and be like, oh, my answer is, 1.06. No, it's not. We have to hit enter one more time and make sure that it actually says the word 0, and that is a solution. We would have never been able to tell this accurately just by looking at the graph. You know, we would have, right? So, but the calculator works it out perfectly for us. So there it is. So now we know one of our solutions is, 0.38196601, and probably keeps going. And what does it tell us to round to? The tenths place. So we can come back here and say, okay, that sounds good to me. So the solution on number one of our solutions, is essentially 4 tenths. Okay? That's this guy right here. When we round it, we round it to 4 tenths. Okay? You could do that, yeah. I like to do this quickly sometimes. You could say, that's how I did it on the answer key, I believe. So, yeah, that's probably even more accurate. About 0.4. How about that? Okay? All right. And then guess what? That was only one solution. How many solutions does this have? It has 2. So guess what? We just do it again. We just do it again. And this time, we're going to focus on this right-handed x-intercept, and we're going to hug it. Okay? So let's do it again. And let's find the second one. So we're going to go second calc. We're starting over. We're going to find the 0 of the function. So that's the second choice. I'll press 2 there. And I need to make sure that I am not hugging both, right? So I don't want to be so far to the left that I'm hugging both, because then it'll never find the second one. It'll stop at the first one. Okay, so I want to make sure that I'm close but to the left. And I can hit enter right about there. And then I want to just scoot over to the other side of it. Get to the right of it. Make sure my x-intercept is between those two boundaries. Hit enter one more time. Make sure that you've hit enter enough times that this says 0. Okay? And there's our second solution. Okay? So are we okay with 2.6 as our second solution? Yeah. So our second solution here, and you just solved the quadratic. Okay? You just used the calculator to solve the quadratic. Right? But that's it. And if the answers had been pretty, this still would have worked. But more importantly, this is really our go-to if we're solving something that has irrational decimals as its answer, or even just, you know, any decimal really or fraction as an answer. This will work every time. So remember, yesterday I told y'all there are 5 total methods you're going to learn to solve quadratics. Not all of them work all the time. Okay? There are some that only work for specific special cases. But this one right here, as long as you have a calculator that you can do this, as long as you have a calculator, the graphing choice is one that always works. Okay? Because you won't always have a graphing calculator, for starters. There's a couple of other reasons too, but and there's actually a couple others that are probably quicker and easier. But yeah. Yeah. You just move it farther right so that it's still to the left of the second one. So like when I moved it, I just positioned the left boundary over here and then the right boundary over there. So it's still hugging the second. So, but you want to make sure it doesn't hug both, because then it'll stop at the first one and it'll never find the second one for you, right? So you want to make sure that it's past the first one, but still to the left of the second one on the right, and then you hug it to the other side. Okay, let's try it again. Let's do number 2. Okay, try number 2. Let's go ahead and plug in our equation. Let's go back to y equals. This one is x squared. What is it? Minus x? Minus 3. Thank you. Minus x minus 3. Okay? If you want to go ahead and graph it so you can see what it looks like and that it matches the one you have, you can do that. Well, that and the regressions, but yeah. The line, the curves of vested and the stat plots. Yeah, so everything's calculated today. Yeah. Okay? All right. Okay, so let's start looking for the left one. If you haven't already, we're going to go second trace. That gives us a calc menu. We're going to choose a second choice. We're going to get to the left of this intercept. And then we're going to get to the right of that intercept so that it's being hugged by the two boundaries. It's sitting right in the middle. And then we hit enter one more time. And it looks like this 0 is at negative 1.3. Is that what y'all got? Negative 1.3. So I can come back here and say, okay, one of the solutions here is negative 1.3. Okay, that's one solution to that quadratic. Now let's just do it again for the other one and we'll find the second solution. So we'll go back to our calc menu with second trace. We'll choose the second option. I'll get closer but still stay to the left of it. So I'm getting closer to it, but I'm staying to the left of it. Okay. And then I'll scoot over to the right. Make sure my x-intercept is between my boundaries. I hit x one more time. The other solution is 2.3. So that's positive 2.3. Okay. Try the very last one on your own. All right, try number 3. Yeah. No, I'm not going to take off for that. So, okay, so let's do this last one. On this last one, negative. Let's go up here really quickly. You've got negative. Make sure you use the negative, not the minus. X squared minus 8x. And then what's the last part of that? Minus 13. Okay, so if we graph it, you should get something that looks a lot like the one you have on your curve. You can see right here it doesn't land on whole numbers, so we are going to use our second trace to find the calc menu, find the first zero. Okay, so we need a left boundary. I don't even see this guy right now, so make sure I get all the way to the left. Okay, hit enter there, and then get to the right of it, and hit enter there. Make sure it's in between the boundaries, hit enter. So did y'all get about negative 5.7 for the first solution here? Okay, good. So everybody feel comfortable with that? So our first solution is at about negative 5.7. Okay, and then we just work it again to do the second one. So we go back to that calc menu, choose the second one, choice. We'll get closer, but we'll stay to the left, right? So we'll get closer to it, and then we'll go to the right of it, and then we'll hit enter one more time, okay? And you get negative 2.3, really, when we round it. So the other solution is at negative 2.3. All right, so are we feeling really good about using the calc function of our calculator to compute the exact x-intercepts? Are we good with that? All right, awesome. So then let's talk about this word problem right here, because this lets us play with another feature on our calculator. The height of a toss in bocce ball. Have you ever played bocce ball? Anybody know? No? It's like a little white ball right here, and you try to get the other ones close to that. Is that how that works? Okay, so the height of a toss in bocce ball can be modeled by this equation, negative x squared plus 4x, where x is the horizontal distance. So notice, guys, this one's similar to the one we did yesterday, but the other one was comparing the baseball one, remember, with the fly ball? That one was comparing the height of the ball over time. 1,000, 2, 1,000, 3, 1,000, right? Until it landed. This one is not. This one is comparing the horizontal distance, like how far out it goes, like, so horizontal distance and vertical distance, okay? So the first thing is, how high does the bocce ball bounce? Are they still asking me about x-intercepts here?
But they're not.
If I want to know how high the ball bounced, they're not asking about x-intercepts, right? The max, the vertex, right? Exactly. So first of all, let's graph it. Okay, we've got, let's clear this. We've got negative x squared plus 4x. Okay, the original curve is going to look like this, but guys, if our axes are distances, what numbers don't make sense for distance? Negatives, right? So we might want to rework our window a little bit if you want. I like to always give it a little bit of a padding there, but not necessarily all the negatives because we don't need them. And then as far as height, same thing. Maybe, I don't know, we'll do 8 feet. Yeah, we can always adjust that if we want. I always like to put the -1 because it gives me just a little bit of this edge, a little extra, but I know that the negatives don't make sense. But this is a pretty good view of the bounce of the ball. So if I want to know how high did the ball bounce, I'm not asking about x-intercepts. I'm asking about who? The vertex. In fact, the height of that vertex, which is the max, the y-coordinate, right? We're looking at vertical. Okay, so, but guess what? Your calculator does this too. It appears to be at about, well, I went by 1, so I guess at about 4 feet. But if it weren't, maybe it was 4.1 or something close, but not quite. And we want to know the exact value. That second trace, this calc menu, calculates the ding, 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 ding. Yeah, it'll calculate your maximum. In fact, it'll give you the whole vertex together, but yes, but. So there it is. So this time, instead of calculating the zeros, we're calculating the maximum. So we're going to choose the fourth choice. And then the rest of this, guys, is very much like what we did. We need to give it a left boundary. So I need to get a little bit to the left of that vertex. Okay, just a little bit to the left of it. Make a boundary there. And then I'll get a little bit to the right of the vertex. Make sure the vertex is in between the boundaries. And then I'll hit enter one more time. Make sure that says maximum. Now, this can be a little tricky, right? Which coordinate are we really actually looking at if we're looking at the max? We're looking at the y, right? Now, here's the deal. This brings up a really good point. Look at the ordered pair. What does the ordered pair say here? Well, it should be 2, 4. But this says 1.999999, all this stuff. So let me just touch base with you about this for just a moment. Sometimes you'll see a really weird decimal like this. It's really close to what you think it should be, but not quite. This has more to do with the pixelation of the screen of your calculator. So unfortunately, our calculators are not like Ultra K, 4, you know, whatever. What is the latest 4K screens? Okay, they're not like all of that. They have these little pixelations. You can even see here the curve is not fully smooth. So sometimes when it calculates, the little cursor can't quite land on the perfect number because there's like it's in between the pixels kind of thing, and you'll get a really close but pretty much same number as what it would be. So this is really 2, 4. If you did b over negative 2a for this, like we learned to do algebraically, you would see your axis of symmetry is a 2, but it's a little bit off because of that pixelation issue. So don't worry about that part. All right, max is still correct here. It is 4 feet. So that's our answer for part A. On part A, we would say, oh, okay, so basically the high, how high does the ball bounce, right? We would say 4 feet here. Okay. How far away does the bocce ball land? Now what are we looking for on our curve if I want to know how far away it landed? The second what? X-intercept, right? Because this is our horizontal distance. So this is going to be over here where it lands. That's what I'm looking for. Now it appears to be at 1, 2, 3, 4 feet away. But again, we can calculate it. Go to our calc menu. This time we will do the 0. And this time we'll do this 0 that's on the right. It's going to take a little bit more. There you go. Hit enter. And then get to the right of it. This is another reason why I like to have a little bit of padding there. And then hit enter one more time. And sure enough, our 0 is at 4 feet. So not only did it have a 4-foot high bounce, but it landed 4 feet away from where it bounced originally. Okay, so 4 feet away. So. And then interpret the intercept. Well, let's go back and look. Where is the other intercept? So we know this one's at 4. Where's the other one? At 0. What do you think the meaning is for that? That's where the bounce started and where it landed. So it tells us that the bounce, you know, had a horizontal distance of 4 feet, right? Yeah. Oh, to the window? Well, just to have a more zoomed in picture. Not necessarily. I mean, I like to get a good zoomed in kind of view, but you could have done it without changing your window. Just a reminder that you can do that. All right, are we feeling okay with the word problem? Yes? Okay. So are we ready for some regression review? So that's okay. It's been a while. That is why we're reviewing it. So still grab your calculator because we still definitely need our calculator for this. All right. So first and foremost, quick review. Before we begin, you want to make sure your diagnostics are on so we can get that correlation coefficient. Okay? So on most of the calculators, you can go here to mode. Okay, and you'll see down here it says stat diagnostics off. If it's off for you, change it to on. If you have an older model that doesn't have this in, so there it is, I'm going to change it to on. If you have an older model, then you need to go to the catalog down here where the 0 is, but it's in blue, right? So you would go second catalog. This is an alpha order. We would look for diagnostics on. And you would hit enter to select it and enter to turn it on. Okay, so that's the other option. I'm not going to go through that because I already turned it on. So you would scroll down through this until you find diagnostics on, and then you'd hit enter, it would select it, and then you hit enter again, and it would say done, it's on. Okay, all right, so just make sure your diagnostics are on. I'm going to quit out of here. And then this is where, remember, so regressions are when, instead of us having the equation like we did on these first 4 problems, This is where we collect data out in the real world, or some sort of data that we've collected, that kind of thing, or we found, and we enter the points and we ask the calculator to give us what equation best fits. It's like finding that line of best fit or that curve of best fit. Y'all remember that? So just a quick review. We're going to enter, for example, for number 6, we have Emery who recorded the distance and height for basketball when shooting free throws. Okay? So we want to enter her table of values, the data she collected, into the calculator. For that, we're going to go to stat. This is all review, but I just want to walk it through with you. And then in stat, that's exactly what we're going to do. We're going to edit. It's already selected, so we just hit enter. Okay? And you'll get a blank list, hopefully. If not, you can erase the stuff that's in there, where you can enter your own data. Okay? So make sure you put your X's in list 1. That'll save you some time later. And the Y outputs on your list 2. Okay, so we're just going to copy our table into this stat edit menu here. So we've got 0, 2, 6, 9, 12, 13, and 15. Okay, so there's all our inputs. Just make sure it's all correct. 9, 12, kind of looks good. And then you can scoot over with the right arrow to the list 2 and put the corresponding outputs. So make sure they line up with the right inputs. 8.4. 13.2, 10.5, and 9.8. Okay? And then once our data is in, we're good to go. We could go ahead and make a scatter plot of that if we wanted. But the idea is we are predicting that this probably has a quadratic nature. So we're going to do a quadratic regression. If our data points look like they make a parabola, it doesn't make sense to do a linear regression if the data is not modeling something that looks like a straight line. So if it looks like it's modeling something quadratic, let's do a quadratic regression and find the quadratic equation that best fits that data. It'll be more accurate, right? So now let's review how to do that. Once this is in, you're good to go. You don't have to worry about this. Let's just go right back to stat. The data is already in there. We don't have to edit anything. We just did that. We're going to actually go over to the right to the calc menu. And this is where we have some regression choices. And what we're thinking is, I think this is going to be quadratic. So we're going to choose a quadratic regression. That's your 5th choice. Okay? So again, you could either press the number 5, or you could just scroll down to 5 and hit enter. And then it just gives you some confirmation. This is why it was helpful. We put the X's on list 1, so this is already, we don't have to change this stuff. Like, yep, we put X on list 1, Y on list 2. I'm going to go ahead and store the equation so I can graph it in a minute. Okay, so I'm going to go alpha, trace, and I'm going to choose that first choice. This will automatically not only calculate the equation, but it'll drop it into this Y equals for me so that in a minute if I want to look at the graph, it's already plugged in. Okay, and now let's go down and calculate. Okay, so there it is. So the top part is telling you, hey, we're putting this in standard form, right? They're kind of giving you the answer key here. It's ax squared plus bx plus c, where a is negative 1.12, or sorry, negative 0.12. B is 2.1, C is so forth, right? So there's our equation. So if we were working this for this one, find a quadratic model. Well, our quadratic model for this is that, and then what's the next part? 2.11. Sorry, so plus 2.11x, and then the C value is 4.22. Yeah. Okay, so there's the model that best fits our data. Is it a good fit? Well, that really relies on that R squared value. Remember this guy? So if this is 0.96, which is pretty close to 1, would you say this is a strong correlation or a weak correlation? Strong, right? The closer it is to 1, the stronger the correlation, the more accurate or close to your points your prediction is. So this is a strong, yes, it is a good fit. Yes, if every single point was on the curve. Like if I made a scatter plot of the actual points for that equation and they all landed right on top, it would be a 1. It is a good fit. How do we know? We're going to say that that r squared is 0.96. That's how we know, right? And then the last thing is use the model, or using the model, what is the approximate height? And really we meant to say max height, so let's say that. What is the approximate max height of the ball? Well, for that, let's go ahead and take a look at the graph. So I'm going to come here. Notice mine's already plugged in. If not, you can just copy the one you just wrote down. But mine's already up there because I told it to go ahead and plug it in there. I'm going to go ahead and turn on my stat plot so it also graphs the data that we had put in so we could see that side by side. Okay, we always need to fix our window. So it looks like our x distances were in from 0 to 15. So maybe I'll leave that at -1 and go to 16 perhaps. And then our vertical height started at 4 and goes to about 4. I'm going to leave that at 16 also. Why not? Let's see what that looks like. Okay, so there are the data points that Amory, collected, and then there's the curve that the calculator computed as the best fit. Okay, right next to each other, pretty close there. Okay, and then we want to know, based on the model, that's our connected line here, what was the max height? So we'll do the vertex for this. So let's go second trace. Let's find that max like we did before. We want to be a little bit to the left of it, so we're good here. Okay. Make a boundary. Then get over to the right of it. And then hit enter one more time. Looks like our maximum is right at about 13 point, or it's predicting it would be. The model predicts that the max height would have been at 13.68, right around there. Okay, so about 13.68. Okay. So just a little review there on regressions. How do y'all feel about that one? Do y'all want to do number 7 or you feel good? Everybody remember how to do stat plot, stat edit, put it in, then do the regression, and then graph it? We're good. Okay.